Hey everyone, in this video we're going to talk about other inorganic compounds. We talked about water already, so now let's talk about salts. Salts are ionic materials that are going to easily dissociate, producing cations and anions in the presence of water. So salts form electrolytes. Electrolytes are needed for muscle contractions and nerve impulses. So we need those ion gradients and we need those ions to allow our nerves and muscles to function properly. Acids are electrolytes that dissociate and release hydrogen ions. A hydrogen ion is also known as a proton. Remember, proton or hydrogen atoms contain one proton and one electron. So a hydrogen ion has lost its electron and becomes just a single proton. That's all it is. So oftentimes we say acids are proton donors and a proton would be a hydrogen ion. Weak acids are incompletely ionized, whereas strong acids tend to completely ionize and release a lot of protons. Bases then are electrolytes that dissociate and release hydroxyls. Hydroxyls are OH molecules, or OH compounds, I should say, and they take in hydrogen. So when you have bases and acids mixed together, we tend to produce a neutral substance. So what is neutralization? The exchange, an exchange reaction between acids and bases that react and form waters and salts. The pH scale is a scale that measures the amount of protons or hydrogen ions in a solution. And the pH scale runs from 0, which is very, very acidic, and that means there's a lot of hydrogen ions in it, to 14, which is very, very basic, and no hydrogen ions in it. Every time we move from one pH number to another pH number, we actually either increase or decrease the amount of hydrogen ions by 10-fold. So the pH of water is 7. That's what the water should be, is 7. Because water is supposed to be completely neutral. Typically when you look at tap water and stuff, it's not quite neutral. It's usually going to have a slightly acidic pH, which is not unusual, but that's because there's other materials in it. A lot of times, well, always, if you're getting water from like a tap in your city, then you're going to have chlorinated water with other stuff in it as well. Anything above 7, then 8, 9, 10 is going to be more alkaline or basic. Anything below 7 is acidic. Blood has a pH of approximately 7.4, so it's slightly basic, and it has to be able to be maintained at that. Anywhere between 7.35 and 7.45, blood works perfectly fine, but if it goes down 7.33 or 7.47, then we have problems, and that's going to lead us to either alkalosis or acidosis. And so we have buffers. Buffers work to maintain the pH. So whereas a neutralizer is going to bring the pH to a neutral number, a buffer maintains the pH wherever it's supposed to be. And so we have a lot of different buffer systems in place in our blood that help to maintain blood pH at 7.4, or between 7.35 and 7.45. So now we're going to get into organic compounds. And I'm only going to start the organic compounds, and then we'll get into another video really going into those compounds. An organic compound contains hydrogens and carbons. Remember that. Organic compounds tend to be much larger than your inorganic compounds. And a macromolecule and a polymer are the same thing. A polymer is a large macromolecule, so a very large molecule made of many monomers, which are subunits of that polymer. And the biological molecules that we talk about are all considered polymers, and they have their own monomers. So these polymers are formed through dehydration synthesis. My dogs are hearing something. If you hear that in the background, it's because somebody's walking by our house or something. They've got to save the world, you know. Monomers are joined to form polymers through dehydration synthesis. So you remove water, dehydrate, and you synthesize something larger. And I'll show you what that looks like. You saw it before, but this is the second time. Dudley, stop. So here we have some monomer. Hold on a second. I'm going to stop this. All right. Hopefully the dogs are calmed down now. Here we have one monomer and another monomer. If we want to link them together, we take a water molecule out between this OH and this OH. We take one water molecule out, we bond them together, and so that's called dehydration synthesis, and we've now made a dimer. If you do that multiple times, then you're going to have that large macromolecule. So the opposite of this is hydrolysis, where you break down the monomers, the polymer, back into its monomers by the addition of water. And so here again we have the two monomers that were linked together, producing that dimer. We add water to the system, and we break it back down into monomer 1 and monomer 2. All right, I'm going to stop here, and we'll start up on the 4 macromolecules in the next video. Bye.